Hey guys, and we're back with another YouTube tutorial. This time we are going to be doing a three-part mini series where we focus on creating this really cool effect. In the first part of this course, we're going to be talking about Houdini attributes. What are they and why they're so important? We're going to be talking about manipulating them and using them for our simulation later on. Part two, we're going to be going over actually creating the RBD simulation, and part three is going to be rendering and compositing. So without further ado, let's get into it. So here we are in a fresh Houdini scene. We're going to go ahead and start off by dropping a geometry node and diving inside. So I want to go over the 5 most common Houdini attributes we'll most likely come across in our Houdini journey. Those attributes are your P, or your position, Pscale, your V for velocity, normals, and your CD. So let's go over each one of these, shall we? So we're going to go ahead and start off by dropping an add node in our scene and creating a point. If you see here in my viewport, I dropped 1 point in my world origin, and the position attribute is stored on that point. So what a position attribute does is it stores your X, Y, and Z values of that particular point in 3D space. So for example, if I were to bring this up 1 on my y-axis, you'll see here that my x is 0, my y is 1, and my z is 0. Now, one thing I forgot to mention is, if you want to take a look at your geometry spreadsheet, one thing you can do is click up here, click on this option, go to your inspectors, and then you put geometry spreadsheet. Your geometry spreadsheet allows you to look at the attributes of your mesh or whatever it is that you're working with. Attributes can be stored on your points, your primitives, vertices, and detail. For the most part in this series, we're going to be sticking with point attributes. So going back to the example, let's say I drop in a grid. And in this grid, let's expand our size here a little bit, give ourselves a little bit more resolution, and drop in a monotone node. Okay, let's kind of work with something a little bit more here, something along the lines of this. All right, let's make it a little bit more. Why not? Okay. If you take a look at my geometry spreadsheet, you'll see that all of my points are being moved around in 3D space. However, the position attribute is being stored for each one of my points on my geometry spreadsheet, and you could see it here. So let's say, for example, my point 0 is -25 on the x, -0.5 on y, and -25 on z. The next attribute that I want to go over is Pscale. Now you're probably asking, what is Pscale? Pscale controls the scale of your object, and you can store a Pscale attribute on each one of your points. So for example, let's say I drop in a scatter node, okay? And let's give ourselves a few more points to work with. And let's drop in a sphere. We're gonna do a copy the points. And I want to instance my sphere onto my points. If you see, all my spheres are the same size. They're all my uniform scale value of 1. Now, let's say I want to randomize my Pscale. Well, first, I need to create a Pscale attribute to be stored on each one of my points. So to do that, I can do an attribute adjust float and go ahead and drop it into our points. And if you see here, it's already creating a Pscale attribute for us on the point class. And you'll see here that it's all 0. But let's say, for example, I want it to be 1. Now all my Pscale is 1. So let's say, for example, we do a random, right? Now each one of my points are getting a random Pscale attribute anywhere between 0 and 1. Whenever you do anything in Houdini that's random, usually what it's doing is it's creating a random value between 0 and 1. However, with the attribute adjust float, we can remap those values to be whatever it is that we want it to be. So let's say, for example, we want a value between 0.1 and 2. If you look at our geometry spreadsheet, you'll see that everything is between 0.1 and 2. And how can we view this? Well, if we go to our copy to points, you'll see that now each one of my spheres are inheriting the Pscale attribute from my points, thus impacting or adjusting their scale. And we can come up with some really interesting results. So let's say, for example, we did a noise, right? And let's go ahead and just kind of work with this a little bit here and move our element size, we can get some really interesting results doing this method. So Pscale, definitely something that we want to have in our arsenal. The next attribute I want to go over is velocity. In Houdini, whenever we're working with simulations, we can create velocities. But to create velocities, we have to go through a few steps. So let's say, for example, we have a mesh that's moving. So we can go in here and let's add in a transform afterwards. Okay. And let's say, for example, our grid is moving up in space every frame. Okay. As of right now, we don't have any velocities being calculated in our geometry spreadsheet or in any one of our points. But the moment I drop a trail node and I have my trail node compute velocity, you'll see that I've created a velocity attribute, which is a vector, and is being stored on my point class. And then you see here that now all of my points have a velocity of 24 on the y-axis. And one of the things that we could do to visualize that is by clicking on this little button here. You're going to be able to see in what direction and how fast my points are moving in space. So let's say, for example, we want to randomize our velocity. One thing that we can do is do a point velocity, and we can keep incoming and do, let's say, for example, a curl noise. Let's go ahead and adjust this a little bit. Now you'll see that all my points are getting a randomized value of velocity applied to each one. Now we can play around with these settings to make it a little bit less random. So once again, kind of like how we did with our Pscale, we can get some really interesting values. Velocities like this could be used for, let's say, for example, a wheat field, or for a particle simulation, or for your volume. So one of the things that we could do to look at our velocity or see how it impacts us in our particle simulations is, let's say, for example, we drop in a null, right? And let's just do a really quick particle sim here. I'm going to do out pop source. And let's go ahead and disable our transform here really quick. Drop in a pop network. We're going to go ahead and copy this, Control C, go inside. In our pop source, we're going to put points. We're going to do use parameter values. We're going to paste our SOP on here. I don't want to take a look at the guide. Let's go ahead and turn this up to, let's say, 1500. Let's turn this to 0. Jitter birth time to negative, and AAA source back. And let's take a look at what's going to happen here. Oh, so everything's going crazy. But what you're noticing is that the particle simulation is being driven by the velocity stored on all of my points. So one thing that we could do to kind of visualize it a little bit better is just lower our life expectancy and press play. And let's look at this real time, first of all. Also, I want to lower this down a little bit more. You'll see that my particles are moving in the direction of my velocity that's being stored on each one of my points. The next attribute I want to look at is color. And whenever you talk about color in Houdini, it's referred to as CD. So let's say, for example, we drop in a color node, right? If you notice, now in my geometry spreadsheet, I created a CD attribute that's in my R, G, and B. And if you notice, it's a constant value being stored on my points. It's all 1, 1, 1. But let's say I were to drop this down to 0.25, you're going to notice that my color changes. And you see the change here on my geometry spreadsheet. How can we visualize this a little bit better? Well, let's say, for example, we do the same example as our sphere and our copy to points. Let's go ahead and drop this on here. Take a look at our spheres. And you see that our spheres are inheriting the CD attribute of our points, thus impacting the color that we see. In the next video, I'm going to show you guys how to sample from a specific range of colors and randomizing that across your points to get a nice little color palette on your spheres. So for now, this is one of the things that we could do to visualize our colors in Houdini. The last attribute that I want to go over is normals. The best way that I can show you how normals work in Houdini is by dropping a box. So let's look at this box, for example. It's storing our position attribute for each one of our points, but we don't have normals. And one thing that we could do to look at our normals is by creating a faucet node. And we can do a post compute normal. If you see here, now we created a normal attribute in our point class. And one thing that we could do to visualize that is if we click on our point normals. You see that my point normals are now pointing away in these directions. In Houdini, whenever you're working with geometry and you get some weird shading issues, most likely that's coming from your normals. Normals are very important and they need to be calculated if you want to have physically accurate shading, or let's say, for example, displacement or bump maps on your mesh. One interesting thing that I also want to go over when it comes to your normals is you'll notice that my normals are pointing away from the sphere and they're going off in this direction. And you're probably wondering how these are being calculated. Well, the way that normals are calculated in Houdini, it basically treats each point as if it were the origin of the world. So what do I mean by that? So let's say, for example, we delete a point here. Let's go ahead and isolate a point. I'm going to create a blast node and we want to delete 7. Point number 7, delete not selected. So now I'm looking at this point. I'm going to create a transform and then move centroid to origin. You're going to see here that is pointing in this direction. So if I were to, let's say, for example, look at our grid and let's look at this top down. Okay. It's going off in this direction, but let's go ahead and create an add just so we can create a point here. And let's put this point with these vectors that we see here. So 0.57735, Control C. We're going to go ahead and put this here, here, and here. And then I forgot to put a negative here. Perfect. So now if you see, my vectors on my normals are pointing towards this point that we have here in space. So whenever we have a piece of geometry and the normals are being calculated from that point, the vectors are being calculated as if the point is in your world origin. That's why you see it going in that direction. And there we have it. Those are 5 of the most commonly used attributes in Houdini. I hope you guys learned something new, because in the next video, we're going to go over creating custom attributes and using those attributes to drive our simulations later on. So if you guys found out something interesting, drop it down in the comments below, or if you want to see something else, let me know. I'd love to hear from you guys. So until then, I'll see you guys in the next video. Peace.